Okay. And there's really not a wrong way to do this. You can solve for any variable you want. The thing is, if there's an easy choice, you want to make your life easy. There should be a fairly obvious choice to solve for here. Why not? I'm just kidding. Y in the second equation, yes? So, y would be equal to what? Yeah, negative 2x plus 1. So then I have to plug that into the one it didn't come from. Yeah, be careful when you're plugging it in, because if you plug it back into the one that you just got it from, you're going to get infinitely many solutions because you just used the same line. So of course. Anyway, 3x plus 2 times negative 2x plus 1 equals 4. 3x minus 4x plus 2 equals 4. Negative x equals 2. X equals negative 2. Yay, enthusiasm. I plug that in over here. And I get 5. Just be careful when you're writing down your ordered pair that you actually write it down in the correct order. X comma y. This should sound very familiar. All right, let's talk about elimination then. And honestly, I really don't care which method you use on the homework or anywhere else for that matter. Okay, so if you like substitution, feel free to use substitution every time. If you like elimination, feel free to use elimination every time. If you're like me and you see an easy way to do whatever you think's easiest. All right. So, let's talk about elimination. All right. I guess I should label this, shouldn't I? Elimination. Which variable do you want to eliminate? There's not a wrong answer, just pick one. Y sounds good. Now remember, you have to multiply one or both of these equations by some non-zero constant so that when you add those together, you get the y to drop out. So I've got a 2y and I've got a negative 8y. So if I make the 2y into positive 8y, then I can get those to cancel. How would I accomplish that? Multiply by 4. Positive 4. Because this is already negative, so that when I add those together, it'll cancel. So I multiply that top one by 4. So let's see, this would be 12x plus 8y, 48, 96, 192. And then this one I could just keep the same. And then I add 21x equals 168. I can divide by 21. Eight. Does this method sound somewhat familiar?
Yep.
Now what? Yeah, you got to plug it back in, and it really doesn't matter where you plug it back in. You can take your pick. I think the top one has smaller numbers, with the exception of the 48. So that's where I'm going to plug it in. 3x plus 2 times 8 equals 48. If I subtract 16, oh, I was like, why doesn't this work? You know, it's definitely a teacher trick to mess up on purpose and see if people catch you at it. That was not one of those times. I just did something dumb. All right, so how about we subtract 24? 2y equals 24, which means that y is 12. Yeehaw. Okay. So, all right. Do you want to do elimination or substitution? All right, well, there's a mixture. I like elimination. We're going to do elimination. Now, which variable would you like to eliminate? Just pick one. Let's do x. So I've got a 4x and a 6x. What do 4 and 6 both go into? 2 goes into both of those, but what do they both go into? 12. And so, if I can make one of these into positive 12 and one of them into negative 12, then I can get those to cancel. So what can I multiply this top part by? Negative 3 sounds good. So I'd have negative 12x minus 18y equals negative 36. And what would I multiply the bottom one by? 2, because I want it to be positive. So this would be 12x plus 18y equals 24. And then when I add those together, so if all this cancels out, what do I get? 0. And I get 0 equals negative 12. Well, crap, that isn't true. So that means there's no solution. Because the lines were parallel. All right. Hey, you substitution fans, that would be my recommendation for this one. I wonder why. I wonder why. So, since y is already solved for, I can plug it in here. So 15x minus 5 times 3x minus 2 equals 10. We distribute 15x minus 15x plus 10 equals 10, which means that 10 equals 10. So what does that mean? Yeah, it does. It really works. Because that means there are infinitely many solutions. Now, understand this. That answer in itself is not sufficient. Remember that we have to understand the nature of the solutions, because just because there are infinitely many doesn't mean I can pick any x and y and have it be a solution. Okay? They follow a pattern. So what I'm going to look at is I'm going to look at this piece right here because I've got it solved, right? So whenever you have infinitely many solutions, you want to solve for one of the variables. And then you let the other variable be some arbitrary value, say A. I don't know why textbooks like A, but they like A. So if I let...
Pardon the interruption. Tennis players, I'm missing like 6 of you guys, so if you could politely let your teacher know that the bus is already left and you better hurry, that would be great. Have a great weekend, Bulldogs, and there's no pizza after school for sale.
I forgot to pause the video. We got that lovely announcement from dearest Robert. Okay. So if we let x be a, then y would be 3a minus 2. Now, I don't really care. You could do x and then 3x minus 2 for all I care. I just know that textbooks like to use a different letter for some reason. I don't have a good reason for it. So the idea is you want to come up with what all the solutions look like. So if you know an x, that's the y that goes with it. That gives you infinitely many solutions. Sound good? That's where we're going to stop for today.